Hello, my name is Matt Westerveld from Metrix CreateSpace, and I am here to present results for Darpa PA 1152, an inexpensive, practical, textile-based computing and communications platform. Our project has four main areas of focus: power storage and charging, durability, cross-garment communications, and modularity at the garment boundary. We do not focus on applications at this time.
In iteration 1, we focused on building some software for our graphene supercapacitor, testing our materials, and doing the assembly of the electronics reference design. We built the reference design, the microdisc here, from our first panel, and we discovered that we really needed solder masks, so we had to go back and build another panel. This one we stopped before the routing and applied a structured polyimide film, which we then laminated in our press. This gave us boards with a polyimide solder mask rather than using a chemical process. We do like this a lot. We have some registration problems at this time, but we think it's due to the choice of the adhesive that we used before it went into the press. We were able to assemble one of the boards that registered correctly, and we've been able to validate this electronically as well as figure out some bugs in the design. The bugs are superficial, just component choices, and we've been able to get through that. We built a pogo pin test jig using the other laser, which is nice. It just plugs in. We were getting some weird results through the debugging. We ended up tacking on some solder wires. Our materials progress is moving along. We've got mixed results on the polyimide. We're ablating through, but it's causing some problems on the back. And there's this tearing feature that we're seeing that is a little strange, because we're getting through the material, but it leaves a little bit, and then if we blast it again, then it goes all the way through. So we just need to work out the bugs there. We also picked up some aluminum over PET film, and we were able to get nearly the same results that we got on the Kapton, which is where we have a little bit of this tearing, but this was using a baked-in design that was supplied by the laser company. So we're not sure if we're having problems with our material or if we're having problems with the laser. We're going to figure out what's going on there, and then we'll be able to move to our structuring step of the graphene. On that note, we've moved from drawing our interdigital fingers by hand to writing a script that generates the fingers as well as a well to pour the graphene in pre-structuring. This was a bit tricky, file formats, and well, it was just a bit tricky. So this took a little bit longer than we thought it would, but we're very pleased with the results. We've got software now that we can tweak. These are currently set at 50 microns, and we're going to do some work on the well, but it seems to be great. This is what's going on in iteration 1, and it's basically a bunch of work towards the further iterations, which are starting now. So.